Dear colleagues, let me present the main results of research on the topic mathematical model of the energy resource consumption process in the form of a random process with piecewise homogeneous components. The need for economy and optimal consumption of energy resources determine the relevance of the task of analysis, control, diagnostics, and monitoring of the relevant energy resource consumption processes, such as electricity, water, natural gas consumption, etc. Such tasks are solved with the help of specialized automatic systems. These systems depend on the adequacy and accuracy of particular mathematical models. So, the task of developing adequate mathematical models of such processes remains relevant. The processes of energy resources consumption by objects of various scales are both stochastic and periodic in nature. There are a huge variety of scientific and technical articles dedicated to the construction and application of mathematical models based on random processes theory. This paper proposes a comprehensive generalized model that combines both deterministic and stochastic components of the energy resource consumption process. This model is presented in the form of a random process, which consists of the sum of three components: trend, several piecewise homogeneous components, and stochastic component. In general, the research process of random processes of the energy resource consumption can be described as shown in Figure 1. Here, a proposed model is presented by the expression 1. In this model we have three components: trend, deterministic periodic component, and stochastic component. Deterministic periodic component V can be as a sum of many components with different periods and amplitudes of oscillations. In this case, model 1 can be presented in the form 2. The obtained results of statistical processing, which make it possible to decompose the implementation of random processes into components and find change points, make it possible to specify the general model. Equation number 3. Here, in this model, we use special indicator function equation 4, and general period of observation is divided by change points into n sub-intervals. At each of the n intervals, the trend and fluctuation components are described by some deterministic functions. To confirm the adequacy of our model, we use statistical processing, and this process of statistical processing consists of two stages. First, the composition of the process implementation into individual components. At this stage, we use singular spectrum analysis method. And stage number 2, change points detection, and using them to divide process components into fragments that correspond to separate intervals of process homogeneity. At this stage, we use the statistical unit exact linear time method, or just PELT method. Some results of statistical processing you can see on the following slides, such as the results of the composition of the electric energy consumption process. There are two parts of this figure, slides number 9 and 10. And figure 3 shows the results of statistical processing of dividing the electrical consumption process and its component into homogeneity intervals, which are represented by vertical lines in the red color, and the results of the composition of natural gas consumption process, and dividing into intervals and the results of the division into homogeneity intervals, the implementation of water consumption process. Figures 6 and 7 show some of the results of approximation, especially approximation of trend component and some oscillatory components by using sinusoids. General analysis of obtained results. As a physical interpretation, of course, of change points consists in the transition of the network of energy consumers from one established mode of consumption to another. Naturally, each network of energy resource consumers has its own individual characteristics, and the tasks of decomposition, change points detection, and approximation of deterministic components are solved during the study of the particular process implementation. And conclusion. In this paper, we propose a model of the energy resource consumption process, and this model generalizes known stochastic models and combines both deterministic and stochastic components. Prospects for further research are clarification of the nature of the stochastic component model of a specific implementation of the process and modeling of both each component of the model and the process as a whole. Thank you very much for your attention.